Welcome to the Making Sense of Your Data. This is where you're really going to find out what you can do with the data that you've captured now that you know how to capture Netmon traces. In this lesson, we're going to find out how to get to the bottom of the capture. One of the nice things about Network Monitor is that you can view the data packets in real time. I talked a little bit about that before, but it's really interesting to look at patterns and be able to troubleshoot based on looking at those patterns of the data being captured while it's actually being captured. But sometimes it's not so easy to get to the bottom of the capture so you see the last data packet that came in. So I'm going to show you how to get to the bottom of capturing data, then how to get through, find that needle in the haystack. How do you find just the data packets that can help you troubleshoot your issues? So I'll show you how to find the data. We'll build some filters, and I'll show you how to do filter expressions. I'll show you how to build some custom filters and also how to just use some of the built-in filters that Microsoft already has for you. I like to use those as cheat sheets. So if I'm not sure how to build a filter, sometimes I'll go pull up a similar filter that's already built in and then just make a couple changes to it. So I'll show you how to do that as well. Then the last two topics is adding some color to your filters to make data packets stand out and be a little bit more recognizable. The last topic is going to be adding comments. There are going to be times when it takes you 2 or 3 weeks, or at least 2 or 3 days to keep going back into a network trace and try to figure out what the issues are. It's nice to be able to comment on data packets so that you can review your previous comments and know where you've picked up and what you were planning on troubleshooting in the first place. Getting to the bottom of that capture. The first data packet that is captured will be listed at the very top. Now, if you've got a trace that's been running for 2, 3, 4, 5 minutes, it's difficult to get all the way down to the very last one that was captured. So I'm going to show you a nice little auto scroll feature that will just pop you right down to the bottom, and it's a toggle, so you can go down to the bottom and then back up again. Let's get right into it and go see how to get to the bottom of your captures. I'm on my DC1. This is the Wired Brain Coffee WBC DC1. And I also have DC2 up and running and a client, just so I could get some type of traffic in here. Now notice how everything is set up. It's the way we left it the last time I was here. I had already collapsed the time offset, time and date, and the number of frame or the number of packets that have come in. You notice down here at the bottom, you can see that currently I have 1,490 frames. So this is giving us a little bit of data to play with. But if I wanted to find out what is the most recent packet that has been captured, I could come over to the scroll bar and scroll down, and as more packets come in, it pops me back up higher again. So you would have to continue to scroll down again and again and again and again. Unless you use, let's pop back up to the top, the auto scroll feature. I can either click auto scroll or the hotkey is F8. So if I click on auto scroll, notice where it put us? Right down to packet 1490, and you will stay at the bottom of your capture. So when more packets come in, you'll still be able to see packet 1491, 92, 93, 94. It doesn't pop you back up to the top again. Notice as the additional packets come in, I had 1490 highlighted, but as the newer packets come in, I'm getting to see the latest and greatest packets. So you're looking at data that's being captured in real time. That's how easy it is to use your auto scroll feature. Next is finding the data, which is probably the most difficult thing to do. Is in a live environment, you're going to have thousands and thousands, maybe tens of thousands of packets in a mere few seconds of capturing data. So trying to find the data that you're looking for to troubleshoot a networking issue, that gets to be a little bit tricky. So what I want to do is I want to show you how to filter the data. You can either filter it to show you specific data like traffic between 2 machines, or possibly you just want to look at all DNS traffic or DHCP traffic if you want to stick with just protocols. Or you can also filter out traffic. So you can say, don't show me any broadcast traffic. That's just noise. I don't want to see broadcast traffic right now. I want to see everything but broadcast traffic. Then Microsoft has some really cool built-in standard filters for you. And one of the nice things that they've done with these filters is they've given you all kinds of information. It's like when you use one of their filters, you open up a help file. It explains the filter to you, and then with comments in the filter, it'll tell you which pieces of data to change if you'd like to customize the filter a little bit more for yourself. And then, of course, after you know how to do built-in filters, you can create your own. Now, the things that you can filter on things like properties, like an IP address. You can filter on a protocol. Show me all the DHCP or DNS traffic. Show me all the LDAP or SMB. Or protocol elements. And that is easier to show you than it is to explain it. So I'm going to hold off on protocol elements, but I'll show you exactly what I mean by that. The way that Microsoft allows us to create the filters is referred to as limited IntelliSense technology. What does that mean? It means instead of having to know exactly how to type out these commands, know where the spaces go, what the operators are equal to, not equal to, you can just put in a dot, a period, and then choose from a drop-down list. In this example, I've used dot, show me protocols, dot, and then you'll get a list of protocols. And from that list, you could choose ICMP, you could choose HTTP, DNS, DHCP, ARP, any traffic that you want. Building those custom filters, well, your filter expressions are pretty much the same as building an equation. They're usually separated by the word and, or the word or. And the C representation of those two, the and is the double ampersand. The C representation of or is the double pipe. So you can choose if you want to type the word and or use the C representations of either of those. Your basic operators, if you want something to be equal to, it's two equal signs. If you want it to be not equal to, it's an exclamation point or bang and an equal sign. If you don't want to see something, you're saying, do not show me all DHCP traffic, you would put bang DHCP. So that would filter out the DHCP traffic. The example I have for you here is viewing IPv4 traffic between a source and destination computer. So just between these two IP addresses, you would type in IPv4 dot address equal, and then put in one of the IP addresses and another IPv4 address equals to, and the second IP address. In this example, I didn't actually tell it which was the source and which was the destination, so I would get any traffic that is running between these two machines, regardless of the 10.50.50.50 machine sending or receiving the data. I would get both sides of the conversation. You can get a little bit more fancy if you want to and tell it to just find out all the source traffic from an IP address, or you can do destination traffic to an IP address. Let's take a peek first at the built-in filters. Then we'll take a look at the custom filters that you can create. Back on our server, we're down to 1,530 packets. I'm going to tell it to go ahead and stop the capture. And once it is stopped, and you know that it's stopped because the start becomes selectable again. In the display filter, let's go take a peek at just what kind of traffic we have first. I see some SNTP, I see ARP, TCP traffic. There's some DNS, MSRPC. Let's just see what kind of interesting stuff we've got in here. FRS. NetBIOS name service traffic, SNTP, there's some browser traffic. This is a machine that has just announced itself on the network. And we scroll over. I can see that that is the WBC DC1 machine that is announced its presence so they can all figure out which one's going to be the master browser and go through creating those browsers for each subnet. Anything else that's interesting in here? Oh, we've got some LDAP messages. Lots of DNS going on in here. Well, let's take a look at those built-in filters. So we're going to go to the display filter window, and under load filter, we can check out the standard filters. Let's see, you've got a standard filter here for basic example. Let's just choose show me all the DNS traffic. And when you choose one of the built-in filters, this is what you're going to get. It's going to look like a lot of information to start with, but it's really not. If you just take a couple seconds and read it, the double forward slant is indicating that that is a comment field. So this is not part of the filter, but it's explaining what you will be seeing in the filter. So this is telling us that this filter is going to show us all the DNS traffic, and any protocol can be filtered by using the protocol name. And you can see a list of protocols by typing in protocol, and the dot will show you a list of all protocols. I mentioned also that if you wanted to get rid of a protocol, you don't want to see it right now, you could prefix it with a not or the exclamation point, which would remove it from the filter. Now notice that I've chosen a filter. We picked show me the DNS traffic. But then when you look at the data that's up here, I'm still seeing ARP traffic and TCP and all kinds of different protocol traffic is in there. SMB, there's some DNS, but I just want to see DNS traffic. One of the nice things about building a filter in this way is that you don't apply the filter until you're ready, because you could build a filter that has more than one expression in it. So you could decide to see all traffic destined to a specific IP address, and then out of that, only show me DNS traffic. When you apply the filter, you'll do that by clicking Apply. And on some of the larger traces that you do, it can take it a couple minutes to go in and figure out which ones are just the DNS packets. Notice that now when we look at our data in the frame summary pane, we only see DNS traffic. That's the only type of traffic that we see. Let's look at another filter. Now there are a couple ways to get rid of what you have in the display filter window. You can put your cursor in there, click Control-A and delete everything, or you could just choose to clear the text. But if you do clear the text, look, the filter hasn't been removed. We're still looking at DNS traffic only. So you'll need to remember to remove the filter. All your data is still there. You don't have to worry that you've filtered out certain types of data and therefore those packets are gone forever. That's not true. So we did one for DNS. Let's look at another interesting standard filter. Let's look at filtering out noise, which could be either broadcast traffic, or we don't want to see remote access service or terminal server traffic. So I could choose no broadcasts. And then notice what we have in the display filter. Lets us know that in the comment field, this is removing all broadcast frames. The expression itself is Ethernet dot destination address is not equal to broadcast traffic. If you wanted to see all broadcast traffic, here's a little hint for you. You would type in Ethernet dot, and then from the menu, choose destination address, and then type in the equal broadcast. Let's go ahead and apply that filter. The nice thing about getting rid of the broadcast traffic is quite often it is just noise. So instead of sifting through a couple 100,000 data packets, sometimes getting rid of broadcast traffic can get you down to just a few thousand data packets, depending on how chatty your network is. I'm going to clear that text and remove the filter again. Let's take a peek at building your own filter. Notice I don't have any filters already created because I haven't created a filter and saved it. Once I do save a filter, then we would have a list of my filters that I've created. Let's go over and find just we're going to start with just a protocol. And the first protocol I want to look at is going to be ARP traffic. But before we make our choice, look at your options. And see how nice it is that when you put that dot at the end of protocol, that is the IntelliSense that brings up this menu for you. So you don't have to remember what type of traffic you're looking for. You can cruise through and just choose it. But you've got all kinds of protocol traffic. I've never counted these, but there's quite a huge number of protocols that are built in for your filters. I'll cruise back up to the top and let's just grab ARP for now and apply our filter. Once the filter is applied, we can see here that we have ARP requests and ARP responses. And if you remember from Networking 101, ARP is for machines that have an IP address of a machine they want to talk to, but the machines don't really talk to each other via IP addresses. They talk to each other over MAC addresses. So in an ARP request, let's look at this for an example. This is the machine 10.10.10.51. I know that is my WBCDC2. He's asking for the MAC address for the IP of 10.10.10.50, which is WBCDC1. Now if we were to save this filter, give it a name, we'll keep it very basic, ARP filter. Now we go under Load Filters, My Filters, see how the ARP filter shows up there. So as you're building your filters, and keep this in mind, you can always reuse filters that you've saved. But if you just build filters and then clear the text, there's only a short amount of history that will be saved for you. So here we can also see protocol ARP, but notice we don't have very many entries in here, so it's not like it will save hundreds and hundreds of them if you need to have lots of filters saved. And you do use your filters over and over and over again, especially on some of the more complicated filters. I think it's a good idea to save your filter and then open an old filter that you know used to work, and then modify that for whatever different IP address you're looking for or different type of traffic instead of having to rebuild them from scratch. Most of us don't work in Network Monitor all day, every single day. So it can be difficult to try to remember how you built a filter 6 months ago to look for a specific type of traffic. Just go ahead and save that filter and you won't have to worry about rebuilding it. I'm going to clear the text again. Remove the filter so I get all our traffic back in. There's all 1,530 packets. And now let's look at IPv4 dot, we get our menu. I'm going to choose address, space, 2 equal signs, and then 10, 10, 10, 50. And apply that filter. So what I'm trying to do is just find data packets that are either sourced from or destined to the 10, 10, 10, 50 machine. So that would be any packets destined or sourced. And as you can see up here, we will either have, here's the source for DC1, and this is a packet that was destined for DC1 from DC2. If you wanted to continue on that, you could say, and we need a space in there, IPv4 address equal to 10, 10, 10, let's just say 51. And now we have just the traffic that is between 10.10.10.50 and 10.10.10.51. And it's all protocols of traffic. So that's an introduction to filtering, just to kind of get your feet a little bit wet and show you that if you start out with typing in protocol or in this scenario IPv4 and put a dot, you do get that IntelliSense menu of items you can choose from. Makes it much, much easier to build your filters. you noticed that I could do multiple filters. Then they can be applied at the same time, and you can save the entire filter expression if you would like to. Makes it much easier to use them later on. The next topic is adding a little color to your filters. Well, it's nice to be able to have data packets that just kind of jump out at you, and you can highlight them. You can turn the background color one color and the text a different color. Anything you want to do, any combination of adding color to your filters. You can also save the color and use it in all captures that you open. Adding comments. I'll show you how to go into a data packet and type in your comments, and also how it gets flagged in the capture itself so you can see which packets have comments. Then you can go to that packet, double click on it, and open up the comments to view what you have commented on, or someone else. Let's take a look at adding some color and some comments. I'm going to clear the text, get rid of our filter. Also, I want to make sure that it's removed so we can see we're back to seeing all 1,530 of those data packets. Now, to add a little color to your data packets, we'll go to the color rules. Now, you can get there either from clicking color rules above the frame summary window, or you can also go through tools, options, and your own color rules there as well. To create a new color, let's choose our filter expression. Let's do a protocol. And how about DHCP? Now we can choose what we want the colors to be. Oh, I've got two P's in there. That's not going to work. That's better. The foreground and the background color. Let's change the background color to be bright yellow. Okay. And the foreground color, let's make it red, nice and bright. You can also go in and do custom colors if you'd like to, get all fancy. And if you do go in and start playing around with custom colors, you'll probably want to save the color rule so you can use it later on. You can also choose to have the text style be underline, bold, or italic. And notice this is where you can tell it to save the filter if you'd like. I'm going to click OK. We now have protocol DHCP is set. If we wanted to go in and change that, I'm sure you can guess what you would click. That would be Edit. Opens up to the exact same screen we were just on, so you can change it. You can add to the filter if you'd like to say also include DNS traffic, or you could change your foreground and background colors. We'll pop over here and click OK. And as we start scrolling through, wow, I'm not seeing any DHCP traffic. I think maybe we should have done DNS. Ah, there we go. We scroll up high enough, we'll find some DHCP traffic. Notice what we found here. Our discover, offer, request, and acknowledgement. That would be our client getting its IP address. That's my HR client that we're using for the demo here. And notice how the packets just kind of pop out at you. So it's nice to be able to color code so that you can just scroll through. You could also apply a filter that says just show me DHCP. Apply that filter. And this is normally the way I like to set up filters, is I'll set them up so that I filter to actually look at the data packets, and then if I've done something to surround my traffic that I'm troubleshooting, like using pings as bookmarks. Let's remove just our DHCP filter, and I'm going to add one more color rule. Make it a new rule, and I'm going to use another protocol. This time, I'll choose somebody who does lots and lots of traffic, DNS. The colors, let's go with our background color this time of pink. And the foreground color, I'm going to go with an electric blue, and I'm also going to make it bold text. Click OK. OK again. And now if we cruise through, these guys really pop. Look at that. It's very easy to see which traffic is DNS. And as we saw earlier, when you scroll up a little bit further, you will see all of the yellow. That was our DHCP traffic. So you can color code as many protocols or as many types of filter expressions as you would like. There really is no limit to what you can set up. And the nice thing about this is the color rules are there. They stay there. So every time you go into the color rules, you could simply, if you don't want it to take effect anymore, remove the check mark, but it actually stays there. So it really helps for troubleshooting purposes. Set up the colors that you like on the most common protocols that you troubleshoot, and then you can come in and just add your check mark or remove the check mark based on what you want to pop during the capture. I'm going to leave those guys there. Click OK. And the last topic that we have, let's clear the text out of our display filter again, is comments. For the comments, I am going to go back up to the view and ask it to restore my default layout. To add comments to your frames, the first thing I want to do is rearrange my windows a bit. I'm not really interested in the network conversations that are happening over here, and really under the hood, what the network conversations are simply filters that are already predefined for you, and there's tons of different types of filters. So this would be DNS traffic that we have here, and we expand that. This would be IPv4 DNS traffic between 10.10.10.50 and that 51 machine, and it's conversation ID number 1. We also have some system traffic, local security authority subsystem, LSAS. So network conversations are really just predefined filters that are built in to display the data for you in more of a conversational mode. So just between certain machines, or built-in filters choosing specific protocols or processes. As you can see here, LSAS is the process name. I'm going to close network conversations for now. Now, to add frame comments, first you have to find the frame that you would like to make a comment in. So I'm going to create a display filter. Protocol, we'll choose DNS, and apply that filter. Let me scrunch this back out. So the first DNS packet is actually frame number 230. So I can look at frame number 230, and then down here in the right corner, notice that there are 2 tabs down at the bottom. One tab is dealing with hex details, which I'll show you a little bit more on that in a couple lessons down the road. Frame comments is what we're looking for here. So whatever frame I have highlighted is the frame that I'm going to create a comment for. So here I can enter my title. Let's say it's the first DNS packet. And then I could input, I am troubleshooting, if I could spell, I am troubleshooting DNS issues for the HR client. Tell it to save and close. And then notice what looks different here. So, do you see the pound sign out to the right-hand side of the frame number? If I remove our filter so that now we see all data packets, but I can also see that on packet 230, other than the fact that it's color-coded, so I know automatically it's a DNS data packet, I can also see that it has a comment because of the pound sign or the hash out to the right-hand side. Notice how the other DNS packets do not have that. On the frames that contain comments, you can highlight that frame, come down to the frame comments, and then you can choose to edit that. You can open it, you can cut, paste, copy. There's an undo and a move forward to put your comments back again if you'd like to. So these should look pretty familiar to you. I'm going to choose to save and close. And think about a time when you're going to be troubleshooting an issue and maybe you have to go home. It's 8 o'clock at night and you're done for the day. So you go home, you come back in the next day, and you already have a few data packets that you have input some comments on. Here's my first DHCP packet. When you pop in and open this network capture that you saved yesterday, of course you'll start from frame number 1, 2, 3, 4, 5, because when it first opens, it just goes back to the very first packet that was captured. Now you can go down and choose under the frame comments, next comment. It pops you right down to your DNS packet that was your first comment. Then you can go to the next comment. And you can even scroll back up and go to the previous comment. So it's kind of nice that this allows you to kind of jump around. So when you do put a comment on a data packet, it's a quick, easy way to get right back to that same packet again. Really helpful. If it takes a couple days to troubleshoot, go ahead and just start from the beginning and slap a couple comments in there when you find the interesting packets that can help you resolve your issues. And that's how easy it is to just punch it up, add a little color, and use your comments for those long-term troubleshooting issues that you can run into. What we covered in this session was getting to the bottom of that capture by using the auto scroll button. That way you can view your data packets in real time as they're captured. Next, I showed you how to find the data that you're looking for, and there were a couple of different ways to do that. All of them built around filtering. The first thing we had to talk about was filtering expressions. What is an expression? How do you build it? How is it similar to an equation? So I walked you through that and showed you some of the built-in filters that Microsoft already provides for you and the nice comments that they add in, which is very, very helpful, I think, and also how to build your own custom filters. I also showed you how you can save filters, and those filters are there for every single network capture that you create. So down the line, if you've created filters that will filter out traffic between two specific machines and a special protocol, maybe DNS or DHCP traffic only, you can apply that filter to any captured data. The last couple topics that we finished up with was adding a little color to your filters and commenting so you can hop, skip, and jump all over those data captures and not have to go from packet 1 to 2 to 3 to 4 to 5 all the way down the line every single time you start troubleshooting.